Hello everyone, my name is Apoorva and I'm an engineering management graduate from Northeastern University. So this is my project for the course of data mining and machine learning. The name of my project is like predicting the category of the news using just its headlines. So I've used the crisp BM methodology for this project because of its robustness. So the first part is like stage 1. It's called the business understanding. So as discussed earlier, the main objective of this project like is to predict the category. So there are like various categories like business, entertainment, technology, etc. So, so like we have to predict those categories using just by its headline. So my plan is like to load the data, clean the data, explore the data, clean the data, then like modeling, evaluation, and the final step is like deployment. So let's just go and do the first process, which is called as data acquisition. It is the loading of CSV file. So the CSV file is getting loaded right now. So I'll just give you like brief introduction of all the columns. So here's the like ID. The column names are like there are 8 columns. The first column is ID, second is title, third is URL, publisher, category. So like there are like 4 categories over here. We'll be discussing those. Then story, hostname, and timestamp. So I can show you. So like here's like how the categories are like distributed. You can see the whole distribution in the bar plot, which I'll be showing next. So let's just do the histogram first. Here's the histogram. This is the bar plot. Yeah. So like as you can see, like the entertainment accounts for the highest. Like it's more than like 14 or like 140k. As you can see in the table earlier I've shown. So that's like 152k. Yeah, 152k. So like and now for the correlation I'll be using chi-square test. So here's I'm using the chi-square test. And you can see it takes some time to load. So by the time it gets loaded, I'll just like, oh finally, yeah, it's loaded. So in the chi-square test we get the p-value is like 2.2, like which is like quite less than 0.05 basically. So we can say that these variables are like dependent on each other. So now like from there, like part of the stage 3 like explained below, like the dummy codes. I've created the dummy codes like for each category. So here's the code for the dummy code, and like after executing it, just show you this. So basically this is the dummy code which I have created. So after that, the next step we'll go to is like data cleaning. So data cleaning over here is like the whatever the null values are there, like NA values. Yeah, we just need to replace those NA values by the mode. Over here, as we saw in the bar plot, the mode is like E, like entertainment. So that's what I'm doing, just like replacing those by E. You can see over here. And now see, there are like no NA values over here in the column category. Another option is like deleting all the NA values. Like we can omit them by using these 2 commands. So next we'll go to like again data cleaning, some more cleaning, like adding new columns and removing like few unwanted columns. So for now, like we'll be creating a new column known as text. So text is basically a column which is like title is replaced by, actually it's just the same column as title, but we have removed all the punctuations from it. I'll show you here. So as you can see, this is the column name is title, like there's like apostrophe s, like colons, comma over here. Text is the same thing, just like we are just cleaning all those punctuations. That's it. And like we'll remove this like timestamp, host name, like URL. I think those are like not useful to us. That's why I have removed this column and created a new data frame known as like data news analysis. After that, we'll do some shuffling. That's like this is the shuffling of the data. As my data is like quite large, it's like 440k, so it's quite large. My machine gets hanged basically, and like the system doesn't perform well. So that's why I'm like taking like first 5000 data. I'm doing the analysis on this. I know like this can like hamper my accuracy. Like it does affect the accuracy. Like we'll be getting to know this as we go further. Like we'll be running the model. So crisp DM like stage 4 and 5. Next step is like modeling and evaluation. So as of now we have used like 4 models. So the 4 models are sorry, 3 models. 3 models are like naive Bayes, logistic regression, and SVM. So I've run this. So here's the like, by the time it gets run, I'll just explain you the code. So first is like just the loading of the libraries. Apart from that, like we use like tokenization. So like each word over here in a document is represented as a token, and like each document as a vector of features. And here like we disregard the word order and we just focus only on the number of occurrences like of each word. That is, we represent like each document as a multi-set bag of words. So like again going back and forth. So we like create a corpus over here, and here's the corpus and the cleaning of the corpus, and like to represent like those bag of words in a matrix form, we use like document term matrix. So like here's the syntax for the document term matrix. We inspect it. So the next stage is like modeling. See, as you can see, the whole chunk has run completely. So here's the next stage. It's like modeling of stage. So we use like, as we have used like 5000 data, like 5000 rows. So like we use like first 4000 for training and rest 5000, like rest 1000 for the testing phase. So again, like training the DTM matrix and like cleaning the training the corpus and everything. Like if we run this, I'll show you. So we get those some like 9401 features. So like these are not useful. So we'll just use like feature selection, and like we'll just use like reduce the number of features by ignoring the words like which appears in less than 5 reviews. So we use this, and like and we rerun this again. So it's just reduced to like 1357 again. So this is, we use the convert function over here. We have used like convert function, like the converts the word frequencies like to yes and no. It's like the presence or absence. And here's the like training and testing, like final training and testing is done on the DTMs. And I have here run the naive Bayes. That's why like it was taking time. So that's why I explained you the whole code here. So now right now we'll just like do the evaluation stage, and we'll find the accuracy. The accuracy over here is 29%. Yeah, I know it's like quite less, but like as I said, like it will be very less, because of the main reason is like we haven't used the whole data, like 44k thousand. Though we have shuffled it and we have used just like 5000 data, as my system is like 4 GB RAM. If you use a like higher system with better RAM and like faster processor, definitely that will be increasing. Then like after that we have used the logistic regression over here. So here's the logistic regression I have used. This is like quite fast. Yeah, it runs quite fast, and the accuracy over here is like something 35.52. It's like increased considerably. So like we get to know that like logistic regression as of now is like better than the naive Bayes. So we do some like, so as you can see, the accuracy like 35.52 over here. Like we do some tuning. After the tuning is performed, we just like rerun the model again, and we can see the accuracy has increased like somewhat, like considerably increased to 35.89. Like initially over here it was like 35.52, and like if we like play with it, it increases to a certain amount. After that we have used the SVM model over here. So I'll just run this model. Let's quick as possible, so like I can explain it to you. Okay, so here like similar thing we have done, like DTM matrix, creation of matrix, and like creation of container. So basically what does container do is like it creates a container, like it's for storing, like training, classifying, and like analyzing the documents. So I've run the model. Oh, it was pretty fast. So I've run the model and like predicting over here, and we can see the results over here. That's like, as you can see, like 42, 46, 51, 42, like somewhere it's 35, but it's like mostly like in 40s. So we can conclude that the accuracy of SVM is like higher as compared to naive Bayes and logistic regression. So this was like my project, and the last step is like crisp DM, and like it's like deployment phase. Over here like the final report is generated, and the report submission, and like monitoring and maintaining of the documents, and like what went wrong, like what was good, and like what further improvements are needed. So in this case, like as you can see, like we have used like instead of 44k 440k data, we have used like 5000 data. So yeah, we did that by shuffling the data, but still if you like use more amount of data, like it may be like your accuracy may better increase, or like as of now the imputation technique I have used is like imputing by mode. If you like imputing by some other methods, maybe it will be improving the accuracy. What was good about this project was like all the three models ran and like the further improvements and like further suggestions. Right now it's just like predicting the category. So like next thing will be like predicting the publisher, something like that. So basically this was my whole project. So like that's it. I would like to say thank you so much for listening.